All right, algebra, we are back with our final example for today. And what is it? It's a real world application. So before we get started, make sure you are where I am. So you have your paper folded and you have all of this written out, the space for the equation, the table of values, and the graph. And you have written down the problem, which is this. You put $500 in a savings account that earns 4% annual interest. What that means is that it's compounded once a year. So pause the video, get to this space, and then we'll start talking. Okay, we are back, and if you are back, that's because you have written everything down. So, a real-world application of an exponential function, one of them is exponential growth. So compound earnings in finance. So you put $500 in a savings account that earns 4% annual interest. So here's what we need to do, and I'm going to go equation first. That's just how my brain works. So here's what we have. We have A, we want to find A, we want to find B because we need B, A and B to write our equation, but there is an extra step here. We also need to figure out R, and R is our rate of growth. And it's a little different from our growth factor. Our rate of growth is how much we're growing each time, and our growth factor is how much we multiply by. Now, that distinction is kind of funny, but we just think of it as B equals R plus 1. The amount we're growing plus the amount that we already are. So if our rate of growth, well, let me back up here. You put $500 in a savings account. That is your initial amount. That's the amount that we start with. If we were to write this as a table of values, at time 0, we have $500. Woohoo! Good for you for putting it in a savings account in this imaginary problem. Okay, and it's compounded 4%. So what that means is that after 1 year, the bank gives us 4%, an additional 4%, just for keeping our money with them. Now, it's hard to do math with 4%. And you see, I crossed that out because I wanted to talk through how I got it. So 4% means 4% per divided by 100. So we can think of this as 4 divided by 100, 4 divided by 100, or as a decimal, 0.04. Now it's easier to do math with this decimal. Sometimes people like to say 0.04. So we are going to use this expression of 4% for our equation. And remember that B is 1 plus 4%. So what that means is we have 1.04. So B, the amount that our growth factor is 1.04. Now, if y equals a times b to the x for our general form, we're going to use the exact same equation. Y equals 500 times 1.04 to the x power. And I'm going to show you why that is in just a second. Now, I have my calculator out, and the reason for that is because I'm using my phone to do my graphing, but you could definitely, or do my videoing, but you could definitely use your phone and Desmos to figure this out. So after 1 year, I'm going to have my $500 plus an additional 4%. So if I said $500 times 0.04, that's how much the 20 is 4% of 500. Let me just lift this up so you guys can see it. But that doesn't include my 500. So I'm going to do 500 times 1.04, and I should get 520. So that's where we get our 100% plus our 4%. So that's how we get that. So after 1 year, we've earned $20 because we've allowed the bank to hold on to our money for us. Now, if we take that $520, I'm going to hit multiply, and then that gives me my answer, 520, and I multiply that by another 1.04, I'm going to see how much money I have after 2 years. So I have an additional $20 plus a little bit more. So I'm earning interest on the interest that I already have in my bank. So now I'm going to write this here. I have $540.80. Look at that. Okay. Now, if I keep my money in the bank for a 3rd year and I don't touch it, I don't add any more money, I don't take out any money, I'm going to multiply that by 1.04 again. And this time I get this amount. So I get an extra $20.80 and a little bit more because my interest is earning interest. So I'm going to round this. I'm going to say this is $562.43. I'm going to just, round that 0.2 down because we don't really think of dollars and cents like that in 3 decimal places. Now, here's what I want to show you. That's how much money I have after 3 years. If I wanted to use my equation to figure that out, remember I'm multiplying by 1.04 each time. Well, that's 3 1.04s. And we use exponentiation as a shortcut of multiplication. So I could also say 500 times 1.04 to the 3rd power because I've multiplied it 3 times and I'll get the exact same result. See that? That's the beauty of using an equation, is that we don't have to go to the length of continuing to multiply. Because what if I added to this? What if I made this a question? What if I said, you put $500 in a savings account that earns 4% annual interest, and then I say, how much money do you have after 10 years? Now, you would not want to multiply 1.04 10 times. Instead, you're just going to want to use the equation 500 times 1.04, and you're going to take that to the 10th power because we have 10 years happening. And look at that. Now we have our answer, $740. So you started with 500 and you've made $240 just because you let the bank hold on to your money for you. This is why putting money in a savings account, earning interest, really, we called it earlier in class, get rich slowly, but it really does build up money. Okay, now if we were thinking about this as a graph, certainly you could graph that. You have the power to do that. But why would I ask you to graph this? If you have a graphing calculator, and you all have graphing calculators because you all have access to Desmos. So if I were to do this in my function, I would write 500 times 1.04 to the x power. But you're going to type that right into Desmos, and it's going to graph it for you. It's going to graph it in the appropriate window. Mine isn't the appropriate window, so these TI-84s are actually like quite clunky. So I'm going to change my window to be, x is -1 and y is, or x, my x maximum is, let's do, 800. No, sorry. Let's do it 15. And my y minimum is 0 and my y maximum is, let's do 800 because we're gaining money fast. So now I graph it and I see, ooh, look at that. Oh, it's such a beautiful exponential function. And if it looks a little liney to you, we can just zoom out. And now we see it even more in its exponential glory. There's the graph. Now, when you do this yourself, you're going to have some example. You're going to have, for homework, you're going to have 5 problems. And you can just do this on your phone, Desmos, and take a picture of it, email it to yourself, and put it in a Google slide. You can do it on your computer or Chromebook and take a screenshot and put it into the Google slide. Or you could do it by hand on a piece of paper, and maybe that's easier for questions like this. Take a picture on your phone and send it to yourself. So there you have it, folks. Exponential functions, what we've been doing in the last 3 weeks. Huzzah!